was poking around an API that my husband built. Just a simple shop backend, nothing flashy, no user interface, just raw requests. And at first everything looked fine, but something about it felt unfinished. So I started testing request by request, and then I saw it. Not an error, not a crash, something way worse. So stick with me because I'll show you exactly what I found, how I found it, and why this is one of the most dangerous flaws in modern APIs. I started with the basics, fired up Postman, and I used my key and my user number. So the 2 is my user number and this is my key. Then I sent the request and boom, I got a response. At first glance everything looked normal, except the fact that I was getting the passwords, but I disregarded that as it was just the testing phase. The API worked and the data matched my account, but here's the thing, that API endpoint had something that seemed exploitable. This number here, so the user number. So I asked myself, what happens if I change that number? Not the API key, not the headers, just ID. So I changed from a 2 to a 3. I hit send and boom, I got someone else's data, guys. Same format, different user. I hadn't bypassed the login, I just changed a number. And that's when it hit me. This wasn't just a bug, it was one of the most common and most dangerous flaws in API design. That's when I realized I was looking at a classic security flaw, a broken object level authorization issue, also known as BOLA. It happens when the server fails to check whether a user is authorized to access a specific object. In this case, the object is user number 3. And the server never asked, wait, are you really allowed to see this user's data? Instead, the server only asked, do you have a valid API key? And because we had a valid API key from user number 2, which was me, we could access user number 3's information. Now, this means that anyone with an API key, even a low privilege user, could enumerate other users by cycling through the IDs. Now, the worst part is that most APIs use predictable object IDs like integers, 1, 2, 3, 4, and so on. A BOLA vulnerability like this is trivial to exploit, and nearly invisible if you are not looking for it. It's one of the top vulnerabilities on the OWASP API security list, and for a good reason, because APIs are the backbone of modern apps. But developers often assume that if the key is valid, we are good. But that assumption is what leads to leaks like this. So, I had confirmed that the API was leaking data based on the user ID. But I wanted to know how far it went. How many users could I enumerate? I fired up Burp Suite. Then on Postman, I went to the code snippet, I selected HTTP, I copied this, went back to Burp Suite, and on Repeater, I pasted this, then I sent this to Intruder. The attack type was the sniper attack, and then I configured the payload position here. Then, as payload type, I chose numbers and set the from to 0 and the 2 to 100. And then I clicked Start Attack. And here's where it gets scary. Some requests returned 500, which means internal server error, but others came back 200, which means OK, with full user data, like names, emails, and even passwords in plain text, guys. Look at this, all this information. That's the thing with BOLA, it doesn't always break completely. Sometimes you'll get partial access, sometimes it's based on the object type. But when it breaks badly. I had exploited it, I could enumerate other users, and just by changing the number in the URL, I was able to access their private data. But now comes the important part. How do we protect APIs from this? Well, there's a golden rule in security, and that is never trust the client. If the client says, hey server, let's access user number 3, as we did just now, the server should never just trust that request. Why? Well, because that API key actually belongs to user number 2. But here's the problem in many APIs, and let me show you what that looks like in code. So this is our API, the one that has the ball of vulnerability. Now let me explain it very quickly. So this line here defines an endpoint that lets the client include a user ID in the URL. So if you go back to Postman, this is where we can include the user ID, and we can do that because of this line here. Then we have these two lines, and here the server takes two inputs from the client's request. It takes the user ID from the URL, which is this one here, the 2, and it takes the API key from the query string, which is this one here. With this line here, the server uses the API key to find out who the client is, but it doesn't use that identity to protect the data. Instead, with this line here, it just looks up whatever user ID the client sent, even if that ID belongs to someone else. Finally, with this line here, the server sends back the requested user's data without ever checking if the client is allowed to see it. So basically, when we changed the user ID to 3, the server didn't check if the API key belonged to user number 3. So we could retrieve user number 3's information. Now below, so here, we have the same API, but this time is safe. So no ball of vulnerability. Now let me explain it very quickly. So this line here defines a safer endpoint. Notice that there's no user ID in the URL. So because of that, the client can't choose which user to request. Previously we could do that by requesting user 1, 2, 3, 4 and so on, as you can see on line number 32, but now we can't do that. Then we have this line here, and here the server only takes one input from the client, and that input is the API key, which is sent in the query string. Then with this line here, the server uses the API key inserted by the client to find out exactly which user is making the request. This user ID is resolved internally, not sent by the client. Then with these two lines here below, if the API key is invalid and doesn't match any user, the server responds with the code 401, which is for unauthorized. Then below, in this line here, if the API key is valid, the server fetches data for that exact user, not for any ID passed by the client, because none was allowed. Finally, with this line here, the server returns the data that belongs to that authenticated user and only that user. So now you know how to exploit it, and more importantly, you know how to fix it. But here's the thing, that was just one API, one bug, one mistake. Now imagine thousands of APIs across banks, apps, startups, hospitals, built the same way, rushed, unprotected, and exposed. That's the world we live in. And that's why we are building something bigger. We are working on a platform where you will be able to hack real-world APIs, just like this one. Some of them will be easy, some of them will fight back, but all of them will make you better. You'll get hands-on practice, exploit vulnerable endpoints, brute force IDs with burp, see where developers fail, and because it's also important, you will learn how to defend it too. And here is where I need your help, your feedback. Would you actually use a platform like this, one that is focused only on API hacking in defense? Let me know in the comments. And that's it guys, I hope you enjoyed this video and learned something valuable today. If you did, please give it a thumbs up and subscribe to this channel for more content like this. Also, would you use a playground just for API hacking? Let me know in the comments because your feedback will help me decide if I should keep building challenges like this. Thanks for watching. See you in the next video. Stay curious and stay safe. Bye bye!